So what is RTC? Why do we need it actually? So in real life, human has a need for interaction, right? We interact in real life. So there is a communication happening in this real. So how do we enable this real life IRL communication on internet itself, right? The problem here is that your person is located miles away, and that has to be done in the same way in the IRL fashion that a person is located in the same distance, right? So this is a very tough problem to solve, right? And there are like myriad of protocols and applications out there to solve it, and this has to be done in a bidirectional way. So if you see human communication, it's a bidirectional in nature, and even after this is bidirectional in nature, it has to be in real time, which means if I am speaking and the other person speak, it has to flow like this, right? Then only it will feel coherent. So can you tell me in what should be the latency for a human communication to feel like a human communication at internet itself, on the internet? Yeah, so roughly about less than 100 millisecond. If you do less than transfer of bidirectional of audio video packet less than 100 millisecond, then you can feel like the conversation is very coherent in it, and it will actually feel like a conversation itself. So yep, what are the challenges and all of those things out there, right? So can you tell me some networking protocols out there that you guys use to make stuff out there? Like how can we solve this problem transferring this my audio video packets in real time less than 100 millisecond? Yep. WebSocket. Quick protocol. Oh. Huh? So is it bidirectional and like low latency in nature? Okay, but like now my video is there and my audio data is also flowing, right? And quick and all this protocol happens on UDP, and UDP is lossy, like there is no reliability happening on this, and every packets might take different path, which means on the source your audio packets will arrive on a different time and your video packet would arrive on a different time. So how do you solve this problem, right? So it will be like your audio video are not matching up. So current internet protocols actually fail rendering this. And if you see the client server mechanisms that we have, how do they actually operate? They operate on request response mechanism, that is HTTPS, and they are super slow. So we cannot, and they're not even bidirectional. The closest that we have is WebSocket, and that too works on TCP. But then the problem with TCP is that it's reliable in nature, but then you would have higher latency with it because it will go around 200, 300 because it is waiting for a data. So when like 100 packet comes, and if there is not even a single data, then it will request 100 packet again, right? So it's like you have added a latency out there. So how do we actually solve this problem, right? And so there is something called WebRTC, right? Currently that exists right now. Uh, this is a bit technical, but WebRTC is a peer-to-peer protocol, but then it's actually not a peer-to-peer protocol. The way it operates, right? It has a lot of central signaling component, server component out there, and even if you want to scale it, you would be requiring some kind of servers to scale that WebRTC out, right? And peer-to-peer protocol is an utopia actually, because there are a lot of problems that are associated with it. First problem is that how do you assure that a peer is available on the internet itself, right? That's the major problem. How do you actually reach out to that peer? Because in client server mechanism, a server is always available and he is always listening. But a peer, which is like you might be offline, you might be online, and then you have to ask a separate consent mechanisms out there, right? So this is the present solutions that we have. One is peer-to-peer, another is client server, and one is this WebRTC. So WebRTC is basically a peer-to-peer real-time communication protocol, and major browsers support it right now out of the box itself. So when you make this application, it will run from the browser itself out of the box. Now, how this works is that first it establishes this signaling, right? And this signaling is done with a protocol called IC, right? And it is internet connectivity protocol out there. Now, what this does is that when these IC is established, this person has to find the other peer on the internet itself. He might be behind a firewall or he might be behind a routers. The way the router operates is that it changes your IP addresses to the public addresses. So it's very difficult to reach you out. So how do we actually mitigate this problem? So we mitigate that problem with stun and turn servers out there. And yep, now once you are able to establish and find out peers, and you are able to establish this connection with ICE protocol, now what you establish is a UDP channel, right? So what is UDP? There are two transport mechanism on internet, TCP and UDP, right? UDP is fast, but it is not reliable. And we want low latency, which means UDP is the only options that we have. Now, the quick protocol also actually works on the UDP protocol out there. After this UDP channel is established, we establish this secure encrypted channel that is called DTLS, right? It is encrypted end to end. So this peer establishes a DTLS channel with this channel, and it is thereafter like the data is exchanged, right? Before that, the type of camera, the type of audio, the camera, the codecs that are using, that information is also actually exchanged with other peers, because the data that this camera is generating and the codec that this camera is generating would be required by the renderer of this. Like you have to render his camera on his screen, right? So you have to manage like this bidirectional super fast out there. So for audio video transfer, right, it requires synchronization with my audio and video packets, right? They should go together. So we use a special channel called SRTP with it. But for general data, we use this channel called DTL, SCTP protocol for the general data out there to flow. So this is the how actually WebRTC operate, and with this you can actually enable this real-time communications out there. So if you want to build this real-time communication in your application, WebRTC is the way to go. So have you guys like any doubts in this? Okay. So what are the current problems with it? So actually WebRTC, when you go and scale the WebRTC, it's currently not possible. You end up in a mesh network, and mesh network is not scalable. Now what happening is that you go to an pre-existing solution. One example is Zoom or Agora's SDKs or Jitsi and all of those things. So these are maybe open source, but it is centralized in nature, right? So which means even if a user is using their application, they are using an application that is built on this top-down structure, right? And there's a lot of problem with top-down structure. Now the major problem that we have is actually just like money, right? Everyone thinks that money doesn't have a problem, but there is a problem, right? The government is controlling the money. If we have this decentralized network that autonomously has this monetary and fiscal policy, then we are better suited out there for that money itself. So now, so this, if you can see this graph, this is a top-down system, right? So basically what we need to do here, so all RTC solutions right now are top-down system. And there's a lot of problem with top-down system. This works, but this works on trust, and right? And since it's a top-down, a rent extractive mechanisms happen, right? People try to like seek rent. One is the form of data monopoly. They will try to take your data and monetize that data, or they will try to take the other financial value that you have there right now. In this system, what happens is that wealth concentration happens in a very large disparity. Like in an example of Zoom, right? You guys might be using Zoom for 8 hours, but Zoom stock is like $32 billion right now. So you're getting nothing out of it. So you can see wealth concentration, the value distribution is way different than that's happening right now with the current RTC protocol. And we can actually solve this with crypto economics. The wealth concentration. So this is like how currently mostly our world operates, the top-down system, right? And they use this physical power like police and army and all of those things to maintain their belief. And the belief is actually put from the top, and the people on the down have to believe that propaganda out itself. Like they don't have those. So the belief is actually forced on top of. And there's a central point of failure in this, right? The more the failure happens on hierarchical, the leaves would fail out there. So, anyways, how we can make this system better? You guys are working in Web3, right? Nahin? Magic. So we make this bottom-up system, right? So how we converted this tree structure is that we made this a decentralized network out there, right? So this network is actually trustless. So you do not need to trust anyone, right? And this is verifiable in nature. You can actually verify what other guy is doing in this work and all of those things. And this is Byzantine fault tolerant itself. Value accrues in this network with a help called Metcalfe's law. And it shows that the more the wealth is distributed, the more value the network has. And the more the value the network has, the more it is reflected into this economic state of a system. And yes, it doesn't have this central point of failure right now. So the main thing about this decentralized network is that if you cut this decentralized network in half, it is like a starfish. It will regrow again, right? Which means even after having this no central point of failure, it has this capacity to regenerate itself, right? And this is a major part. And if you cut that into more half, you can like fork it, right? So this is how your fork, soft fork, hard fork, all of those things happen. So this is like Web 2 applications and these are Web 3 applications. So whenever you guys are building Web 3 application, this is how it looks like, right? So this is like read and write and all the data is stored into the repositories of centralized companies. But right now, if you can see all this, you are using this one network for one specific date. Like one network you would be using for Filecoin, the other network you would be using for LivePeer. And it's this aggregation, then you make this Web3 product that gives the USP to your users out there, right? The persona of your users, वगैरह. Yep. So I have showed you like how RTC right now is currently with the top down system. And now what we are doing at Huddle is that we are trying to convert this and make it as a network public good. With this, a planetary scale, verifiable, open, neutral, borderless, decentralized system can be achieved, right? So what do I mean by planetary scale, right? It is just like Airbnb and a hotel chain. A five-star hotel chain would only have hotels in few cities of the countries, while there can be any person in cities that can host these Huddle nodes, right? So it's just like Airbnb. Now you have this planetary scale available. Anyone can use these resources out of the box. And it is open, like everyone can use. It is neutral. It does not give biases on your race, gender, or etc. It's just that if you are this wallet address, you can use this out there. There's no like borderless or country concept in it. And yes, it's decentralized. Yeah, Metcalfe's law. So this is one of my favorite topics, right? So what people actually think is that like we have to decentralize the technology, but the main thing that I would say is that decentralize the value itself. That is the main thing, right? If you can see how the Xe Infinity model operates, right? The token of Xe Infinity is with the users itself, but their game engine is centralized in nature, right? So we want to protect the user's value, and that user value has to be in some chain out there. While you assist this system, their user proponent with these technologies out there, and then you progressively make this decentralized in nature. The Uniswap out there. Now, what's the problem with an open source code, right? If you make an open source code and you publish it on GitHub, its value is effectively zero, right? So why can't you guys make another Uniswap right now? What's stopping you? The code is open sourced on GitHub. Have you thought about this? Huh? Exactly, the network effects. And where is that value of network effects there? In the Uni token, right? So even if you clone the Uniswap, like fork the Uniswap, people won't be using your smart contract because the network effect value has been encoded into that Uni token itself, right? So now you have to like make your own USP, make your own network effects out there. So this is the basis. Like the contract is centralized in nature. Like even Uniswap has upgraded their contract to V3 version, right? That is centralized. But then they are still using this value which is decentralized to the user itself, and it is lying on the blockchain, and they can use this upgraded infrastructure. So what this keeps is that your system is healthy and it is upgraded with the changing environment out there itself. So yeah, so what is Metcalfe's law? So Metcalfe laws actually is a way to evaluate the value of the network itself, right? Uh, so what happens in this is that so can you see this diagram, right? So what Metcalfe law says that if a person joins this network, the network values grows by n square, right? The utility of it. So like you can see, the more people start using your product, the more value it starts to gain. And you can capture that value in the token that you want to make, right? So this is called Metcalfe laws. And so think of it like an Instagram, right? If you make an Instagram clone, so the people would use Instagram because there are other people out there. You will find your friends. So the utility of the network starts to increase if more people start to join into the network itself, right? So this is like a feed forward loop out there, and it will start to grow. And this value, it's like if even a single node, if he's a user just using the your platform itself, it your platform value grows by n square, right? If there is a miner who adds its computational and bandwidth sources, your network value grows by that n square amount. So this is so powerful, the crypto economics, right? It makes like you an entrepreneur out there, out of the box. You geeks can like now code and all of those things. So if you can merge this network effect and good product, you can have this very well rolling out there. So yep, this is the formulas out there, and this is actually very basic formula. And these images and line I have picked it on from the internet itself. So these are not my line. So that's a disclaimer I'm putting out because I made this slide like in last 2 hours. Yeah, Huddle's technical architecture. So we spent like a year just brainstorming on this architecture, how we would come on this architecture. And there are few people out there here also who have built this out there. So we have this robust front end that uses active user feedback to make it much more robust and robust. So what happens is that it is something what people want. It is not something that we want to build, right? So this, with the active user feedback that we have, we make this product better and better. Now we have this media server, right? So these media server are load aware, region aware. So this is like globally placed out there. And then I said that how signaling happened, that ICE protocol out there. And this is the media controller, like how these media servers would be assigned, the logic that is somewhere lies there also. Now in Huddle, within a single click, you can you can live stream on the live peer protocol. Within a single click, you can store on IPFS and Filecoin, right? So this is so powerful on the users end itself. So we have abstracted this technology out. So we wanted to onboard users by trying them the technologies there. So this is the architecture that we have right now. And yes, the best part of it, you don't need to build this again and again. So we have this SDKs, and you can use this SDKs out of the box. So within 5 minutes, you would be having all the capacities of Huddle's infrastructure in your application, right? The global scalability, the RTC feedback, and all of those things. So you not need to spend like a year and all of those things, brainstorming, optimizing, and all of those things. So we have like optimize the infrastructure by putting this dominant speaker algorithm, last 10 algorithms, and then the simulcast, the codec optimizations that we have actually done. So all these things are abstracted out for the developers out there. So if in your dApps, if you want to build this audio video conferencing, or if you are making a wallet and a wallet wants to call audio video call other wallet, that can be done. A WhatsApp of wallet can be built within wherein peer-to-peer calls is happening. So you have like iOS SDKs, mobile SDKs, React Native SDKs, Flutter SDKs. You have like iframes embedded. You have authentication servers. Everything is available within like a few minutes. You just need to like npm install Huddle01, and you have this whole infrastructure in your app. Yep. So here's the best part: progressively decentralization, right? There's no point in decentralizing from the day zero because a network initial condition is very susceptible for its long-term decentralization process, right? If you decentralize from day zero, it might go into wrong hands where concentration and centralize happen, and you can never get that from that state itself. This happened with a lot of folks out there. So what we do is that, and what we want to do is that we want to decentralize the value. We don't want to decentralize the tech. We can decentralize tech progressively. So in our phase one, which is currently complete, we have completed mobile app. It's live. Please, if you can use, you can download it from the Play Store. Web app is live. You can just use it from huddle01.com Chrome browser. We have Chrome extension also, we have Slack bot, and we have Android SDKs, and we have a dashboard also, just to make this experience much more better. Now in our phase 2, we would be outsourcing our computation to community members, right? And we are currently working on this progress right now. And this will make it much more decentralized. Like now, the logic that we were running on server would be run by the people itself, and a proof would be generated for that. And that proof can be verified by anyone. So how do we actually do that? We do this with a help of a technology called verifiable computing. And this leverages this homographic encryption that can compute on encrypted data, right? So what is homographic encryption, right? So homographic encryption is a powerful mechanism in which you can do computation on encrypted value, right? So your code doesn't even need to know the what's value that's there inside it. Like it can work on the encrypted value. So if you encrypt, like if you have this a plus b is equal to c, right? And a value is 1, 2, and b's value is 2, so you get this 3, right? But if you want, but now your code can see this data, it can see this value, right? And when you're outsourcing this computation, we don't want that the people who are running this computation to see this private value out there. So what we do is that we encode this, we have encrypted this packet, and now when this packet is encrypted, you have this homographic encryption. Now homographic encryption can do computation on this encryption, which is very powerful. So it's like now you encrypted A, you get this gibberish data. You encrypted B, you get this gibberish data. Now you can add this gibberish data. It will yield another gibberish data, and when you decode this gibberish data, you have 3, right? So which means we were able to do like, and what does this actually means? Like let me explain. Which means the server cannot see the private data, but it can do its job. It's like your program cannot see the inputs, and it can put the output out there. So this is homographic encryption. And if you are designing, so like there would be a way that you should explore this area also. Now, mm, now we introduce in phase 3, we would be introducing the cryptoeconomic protocol. So what cryptoeconomic protocol would do actually is that there would be various stakeholders into the ecosystem that would be actually defined, right? And they would be contributing this, they will be playing this self game. And this self game will make an impact. This impact will be evaluated, and basis on the global impact that it has made, they would be getting this reward, right? So it's just like how Bitcoin miners are there. So Bitcoin miners compete with other Bitcoin miners, and they get this reward from the protocol itself. So this keeps them incentivized to put this service onto the network itself. So this will be like the nodes, Huddle nodes out there. There would be an incentive mechanism, and these node would be mining, right? And what they would be doing is that they would be doing proof of useful work. So the useful work that they are doing is that they are providing this media service, and the more media service they provide, the more block rewards that they get, right? And this media service is then consumed by the applications out there. Yep. So in fact, this is so powerful. Like now you have a token that captures this network effect. Now you have this token that incentivizes nodes, and now you have token that makes this two-sided marketplace. So you have this a very strong value mechanism accrual that is happening, and once it gets started, is a positive feed forward loop that will go forward only. Yep. So let me give you some stats. This was like I just googled out today only. So Zoom does 300 million daily users meeting per day, right? This is the active users that the Zoom has right now, and this was increased like 2,000% in during the COVID time out there. The Google Workspace has 3 billion active users, right? So you can see the value that these Google people have, and these 3 billion people are we. Actually, these are we. And if we put this crypto economic protocol again into the picture, we can distribute this value equally among the people who are actually bringing value into this ecosystem out there. Now, comparing this adoption number with the adoption number we have on Ethereum, so Ethereum daily active address is only 6 lakhs, 7 lakhs around there, right? And the main major adoption that we have is like a Brave browser. but that also has like 15 million active users out there. So which means we are early, right? And we have this high potential of getting this RTC becoming this layer of Ethereum. So do you know what is Polygon? Right? Polygon is layer 2 scaling solutions for layer 1. That is Ethereum. Huddle RTC infra is this RTC layer for the layer 1, right? So if you want to scale your application, you can use Polygon solution. But if you want to scale, if you want to put RTC, you can use Huddle's infrastructure out there. And this is community owned. Like you can make nodes, you can be part of it, you can control it. Community owned, community government, a bottom up system rather than a top down system. So this is very powerful, right? This doesn't exist right now. And I had showed you the immense potential that it has to cater the adoption number that we have right now. So if we are able to realize this infrastructure, so we would be adding we would enable this true adoption on the layer ones and layer twos out there. Yeah. So regarding Huddle, we are an active team of 20 plus people right now. We have been working for around a year, more than a year, 2 years actually. So we have this open ideas, like if people want to brainstorm and they want these ideas to be there, so we actively accept those ideas and brainstorm over this, and if that's feasible, we get that implementation. We experiment very very high velocity, right? There could be an feature right now, there could be another feature the next day, and there could be some features just waiting in the pipeline to be out there. So we like try to experiment and low fidelity experiment, and that low fidelity gets converted to high fidelity experiments, and then we get these things up and rolling. uh, yeah. So this is like the culture that we have at Huddle itself. Yeah, and yeah, so we are happy. Like if someone wants to contribute to the Huddle ecosystem and all of those things, we are very happy to like have people on board and all of those things, and like get them. And so like your learning curve is like much more better, like because there are already people out there who are working on this problem. So the for people, right? The people, the sooner they involve, it is much better, because your learning is just like a value. The more time you spend at one specific problem, it has this compounding effect, right? So you become more valuable, right? So the quicker you join, the better, the more valuable it depends because of the compounding effect. And what we do is that we try to design this composable and modular architecture out there, and then we like evaluate and measure like what's the potential that it has. Thanks. Yeah, so do you guys have any questions? Acha, directly do.
So one is a technical question where, so there are certain parts of WebRTC that are currently centralized.
Yeah.
So they serve, what function do they serve, and how do you plan to decentralize that?
Exactly. So WebRTC pitches itself as peer-to-peer protocol, but when you actually, in practical way, when you go and implement, it's not a peer-to-peer protocol, because there is an assisting technology of centralized infrastructure that is required to enable this peer-to-peer protocol, right? So the first problem is that how do I find you on the internet? Right? Like I am a peer on internet, you are a peer on internet. Now I want to connect to you. How do I connect to you? Like I'm asking you.
You need some kind of resolution system. Or,
Exactly.
yeah.
You need something to like get this thing up and rolling, right? But if we have this, now if we replace this peer-to-peer system with node-to-node system, so these nodes are already operating, right? Now you can directly connect to the node within a single hop itself. So this is much more decentralized. So just like how if you can see DApp has this decentralized finance and all of those things, you would have this social value, because social values come from human interaction plus this DeFi financial value. And now you can merge this value to have this new use case, and that can be very powerful out there. So it's just like Polygon, right? Polygon is the scaling solutions for layer one. We are this RTC layer for these layer ones. So you can do on-chain conferences, on-chain chats, and on anything will be possible.
Got it. Yeah. Thank you. Thank you so much.
Yeah.
Maybe you have time for one more question. Yeah, so I wanted to understand, is there a way where there are a lot of open source WebRTC platforms that are available, right?
Yeah.
So is there a way where those can be utilized to connect to a similar decentralized architecture like yours? So I
Yep.
wanted to understand if now that you guys are creating your own apps and SDKs as well, that means I'm assuming there is some kind of an implementation on the SDK side also, which takes care of, say, maybe cryptography or the way encryption is occurring. Or is
Yeah.
there a way you can?
Can you put this uh, the screen? और ये स्क्रीन मेरे को मीडिया इंफ्रास्ट्रक्चर दिखाना था. Yeah. So like you can see our front end is communicating with our media infrastructure out there, and this is load aware, region aware out there, right? So now this is very complex. Like we spend around a year, and there's a lot of algorithms also running in that, all of those things. So this is sharded, this is load balance, it has dominant speaker identification, it has active codec optimization and all of those things. So these things are actually currently missing in this open source technologies, right? So our infrastructure is actually built on top of these open source tools only, and we have made it much more better and scalable, right? But we paid a very heavy cost. Like we spent more than a year and out there, and we don't want like people like you paying that cost again and again and again. So it's much better like we build this SDKs out there. Now these SDKs are powerful. Like within 5 minutes, you can use this infrastructure. You can use Filecoin. You can use IPFS and all of those things. And thinking of like making new applications, new use cases that is currently possible out there. So this is there. And then you can see these are like load aware. These are sharded. These in future, like in our phase two, we would outsource these to people, to communities in a verifiable computing way,
Okay,
in a progressively decentralized approach.
so apart from the decentralization part, you're saying there are also additional features that you guys have brought into the system.
Yeah, we have made it much more optimized. So one is like simulcast is there, dominant speaker identification is there, your last and relatively selective relativity is there. So what it does is that you have, so how do we actually scale this system? So scaling system doesn't mean adding more resources. Scaling means optimizing the current resources that you have to drive down the cost of the server itself. Now, in our cases, what we identified was that there were people coming from laptop and there were people coming from mobile, right? So now laptop has a higher screen and mobile has a lower screen. So sending all data to mobile is like a fool's idea, right? You are not utilizing a bandwidth. So you send only that much amount of data that its mobile screen can consume. And dynamically on the voice activity, whenever like another person speak, his data starts to come. Like this logic is also there in the server itself. So this enhances this user experience a lot itself out there. And this is very currently like if we start like with open source tools out there, the learning curve to just to set up a Jitsi takes us tremendous amount of energy out there. And yeah, they are not decent, right? And and then you need to like trust them, right? If I'm hosting a Jitsi server, right? So and you are doing a meeting on my Jitsi server, so I could write a malicious code wherein like I'm seeing your data, right? You have no way to verify that and all of those things. So these are the even the problems with the currently available as a few, yeah, media servers, which is like, so first is this inherent problem and then is this learning curve, and then you have to optimize this case. So ultimately what these SFUs, open source SFUs are basically a marketing tool for their parent SaaS companies, right, which are hosting. So people goes to this and all of those things. So if you are going to their SaaS via their open source technology, why don't we make this network and we get the benefit out of it, right? We as a people. So this is the idea.
Thanks.
Someone I think had a question. Yeah.
You mentioned that you guys will do some sort of verifiability for
Verifiable computing
yeah.
protocol.
So how will that play into the 100 millisecond this thing, the lag which you were talking about for making conversation?
For that you need to join Huddle. It's very complex.
Right.
I can explain, but then I will take 1 more hour. It's a prover verifiable system, and
Okay.
so there is like incremental recursive snarks that is happening. So you can like generate proof within. You can generate proof with a smaller size, and you can verify proof within like 5 or 6 milliseconds.
Right.
So these are currently in research, and then we can get the thing implemented.
I see. Thank you.
All right. Susmit, any parting words you'd like to say to the fellows
Parting
here?
words is that here, please try to contribute because it's a community, right? We want people to be associated, and we want you people to derive value out of it. So the first way would be like start using Huddle and download Huddle, and then maybe some feedback like how do you give and all of those things. Second is that we are currently in our phase 2, and this is the most exciting part right now. So if someone wants to join Huddle and work on this system, we are very welcome to do so and all of those things. Have your team and all of those things. So we are right now scaling our team also, the development part of it and all of those things. And the third part would be, uh, I think these two are enough. Yeah, start using Huddle, contribute to Huddle, and become the community out there. npm install Huddle01. If you're using JavaScript, there are other SDKs also. But on the SDKs, we are actually updating our SDKs also. So right now, just get in chat with our developers and they will help you out on that part. The docs are not currently updated. We are updating those also. Yep.
Right. Thanks a lot, Susmit. Can we have a round of applause for Susmit?